Hi, and welcome to this presentation where we will see how to secure your applications on SUSE CaaS Platform with Cilium. First, what is Cilium? Cilium is responsible of the networking part in SUSE CaaS Platform. Its first goal is to provide the connectivity between the pods, so it takes care of assigning IPs, the routing, and so on, but it can do a lot more. In fact, unlike the majority of other network plugins, it is based on the new technology called eBPF, which is used as a replacement of IP tables. One of the main benefits is that it increases the network performance, especially with very large workloads. Every benchmark between IP tables and eBPF showed that very clearly. Another great benefit is that it allows more when it comes to visibility and filtering. We will talk about this later on in the presentation and during the lab, and you will probably hear me saying thanks a lot to eBPF for that. All right, so what can we use with Cilium to increase the security? Let's embrace network policies to secure our workloads. What's a network policy? A network policy can be used to define how a pod or group of pods are allowed to communicate. So we can define how it is allowed to communicate within the cluster, so inside the namespace or between namespaces with a Kubernetes service and so on. But this is also for external communication. So with the world, you can define if a pod is allowed to communicate with an FQDN, with a specific service endpoint, with the host where the container is running, with an IP range, with just an IP. So in short, the scope is very wide. You can really do a lot of things. By default, Kubernetes already has a standard network policy resource, and this resource is already a good start when it comes to secure your workload, but it is limited. Why is it limited? The reason is quite simple. It's just because almost no other network plugin can do as much as Cilium can. And of course, this is why I'm very excited about Cilium network policies. What are the differences between the two? First, the standard network policy only operates on ingress and egress at the layer 3 and 4, and egress on layer 3 and 4 is still considered in beta, so it's not yet stable completely. On the other hand, Cilium can also operate on layer 3 and 4, of course, and on the layer 7. This means that we can use feature like DNS, like I was saying before, we can filter on FQDN, we can filter on HTTP. So for example, you can just say, I'm allowing this type of request on this specific path only, and if you try to do a method which is not allowed, then you will have an access denied. You have Kafka, you can filter on Kubernetes namespaces, you can filter on service account, you can say, I'm allowing this pod to talk with me if it's running with this service account, is this namespace. So we can, and this is not only that, you can do a lot more. And all of this is because Cilium is using eBPF. So thanks again, eBPF. In general, it's a best practice to use only one type of resources. If you start mixing the standard resource with the Cilium one, it can be very hard to manage. Of course, during the lab, we will only use Cilium network policy. So when we refer at network policy, we are talking about the Cilium one. Some concept now. So by default, there are no network policies applied to a pod or inside the namespace. So all the traffic is allowed in every direction. This can be changed by applying in a namespace a default policy. This default policy can match all the pods inside the cluster, or it can just match a specific type of pod. It's also important to know that if you have a pod selected by a policy, either ingress or egress, then only the rule which is defined to allow traffic will be used. So all the other traffic will be denied by default. This is what we call a whitelist model. As soon as a rule is applied, then on this direction, all the other traffic is forbidden. Another important thing to know is that a pod can be selected by multiple policies. This is usually the case when you have a default network policy applied in a namespace, and then on this default you add a new policy which is allowing specific traffic. But be careful, because in this case the union of the rules will be used and the broader rule is allowed. This means if you have a network policies which is allowing all the traffic by default, and then you, for example, try to only whitelist a specific type of traffic, this will not work because the default policy has a broader rule than the one you're trying to apply. The order of the rules does not matter. It's not like a, let's say, a traditional firewall when you can think of a packet going to each one of the rules, and as soon as the rule is matched, then it will be dropped or allowed. This doesn't work like this. And policy doesn't apply on pod using host networking. This, this is quite obvious, since when you use host networking, Cilium is not taking care of the network. This is managed by the Linux host itself. So you cannot apply network policies on the control plane, so on the API server, controller manager, and so on. And of course on Cilium itself. Okay, so we now know how a network policy is working and what it is supposed to do, but let's see how it's defined. Let's see the rules inside these network policies. First thing, a policy is always namespace. So when you define a policy, you always need to specify a namespace. This is the same principle as when you create, let's say, a deployment inside Kubernetes. This needs to be namespaced. Then you have a couple of fields. The first one, it's a mandatory one. It's the endpoint selector. Here you will say which pod you want to select, or you can also say I want to select all the pod inside the namespace. Then you have to define one of each, minimum, ingress, or egress. Here you will set a list of rules that you want to apply to this selected endpoint. Then it's optional, but it's a common best practice in Kubernetes is to define labels, so then you can get this type of rule using labels. And then you also have the description. This is also optional, but it's highly recommended. Once you have defined your policy, you have a YAML manifest, so you can write this manifest inside a file and apply it in the cluster using kubectl. Again, just like any other Kubernetes resources. You can then see them using kubeget Cilium network policies, and always with specifying the namespace. Or lucky for us, you can use a short name which is CNP when you want to get these network policies. Before seeing some example and how a policy looks like, let's have some quick hints. Inside ingress and egress, when you match an endpoint in each kind of direction, you can have several rules applied to it. So you can match an endpoint, you can add some rules for the port HTTP, for the port HTTPS, and on top of this, you can specify the protocol. You can add an extra set of rules with HTTP again. So this is always a combination of rules. It's important to remember as well that rules must be defined on both sides. Because as soon as you have two pods which need to communicate together and these two pods have network policies applied to them, then you always need to create a whitelist rule in ingress for one side and egress on the other side. That's just very important to remember that when you allow one side, you always need to allow the same rule on the other side. The last hint I have for you is that when you apply policy to a pod and you don't specifically allow some traffic like DNS or the communication with the API server, this is not possible. This is very logic when you think of the nature of network policies. But the first time I started to play with network policy, I was allowing some traffic and I was wondering why I could not resolve any DNS anymore because this is something that you take for granted when you have a Kubernetes cluster. You can always request DNS or you can always communicate with the API server. So just keep in mind this traffic has to be specifically allowed as well. The very last topic before we see some example is how to test and debug when you start using network policies. The first one is this list is Hubble UI. Hubble UI is a web application where you can visualize the pod traffic in real time and you can see if this traffic will be allowed or denied, and you can get some very interesting information about the source of the traffic, the destination of it, if the pod was selected by a network policy, and so on. This is a really great tool. The second one in this list is quite my favorite, but it has a drawback that this command line has to be executed inside the Cilium pod. This means if you have a multi-tenant cluster and you're not a cluster admin, you probably don't have access to the Cilium pod and you cannot hopefully execute anything inside this pod. That said, this tool is a very powerful one. How does it work? You first type in the CLI Cilium policy trace and then you can ask Cilium if the traffic will be allowed or not. You define the source traffic, so you can say I want the source traffic to be this pod A with the destination pod B, let's say, and you can ask Cilium if the traffic will be allowed on this port, on this protocol. This is very powerful. The last one in this list is a more traditional approach when it comes for testing. The idea is to create some pods with all the debugging tool you need, like Netcat, Nmap, curl, ding, everything you need in your application to test the communication. If you want to see if a pod is allowed to communicate with MySQL, you can add the MySQL client and test from this pod if it can connect to the MariaDB, for example. And these debugging pods must have the same labels as the original workloads. If you have, let's take again the MariaDB example, you have this MariaDB pod with the label app equals MariaDB, you will create another pod in the same namespace with this label app equals MariaDB, but you will use the image with all the pods, with all the tools you need, and you will do the same on the other side. So having the same labels, which means they will be selected by the network policy we are trying to test, and then we can see if the traffic is allowed or not, or if the rules in general are working correctly. So here we've seen three ways to test and debug, and of course we will see the three of them during the lab. Now let's see some concrete example. In the next slides, I've concatenated the list of the network policies we use in the lab with an explication next to each. We will see the filtering at several layers, but don't worry, this part is mostly intended to be used as a support for the lab because it's really a lot of information, so I will just go over quickly and let you have a look later on. The first example are the default policies, and you can see how it's possible to allow or deny the traffic from or to anywhere. The next one is the layer 3 based on label. What we see here is we have in the point 1 the endpoint selector, where we say that we want to apply this policy to every pod with the label app equals Prometheus. And at the point 2, we see from which endpoint, so which pod, we allow the traffic. Here we can see that we will allow the traffic from the pod with the label app equals Grafana in the namespace named monitoring. So basically here we allow Grafana to use Prometheus as a backend to read the metrics. We can also define policies to Kubernetes service. Here we say that the Prometheus pods are allowed to communicate with a service named Kubernetes in the default namespace. So basically this is how you allow a pod to talk with the Kubernetes API. We can also filter on IP range. We can even go further. We can restrict even more a subset of IP within this CIDR range. If we take this example, we have a /24 and we could just allow 2/28, for example, from this /24 to go in ingress or egress. At the layer 4, this is nothing else than a layer 3 that we've seen so far, and we add an extra rule. We've seen before that we can add a list of rules to each endpoint, so this is our first example. We, like almost always, use labels to match the other traffic, and here we can see at the point 3 that we add a new rule where we allow a port and a protocol. In this example, this is what we can do when we want to allow a pod to resolve FQDNs. This is basically what was in the hits I was talking before. Here, it's like the previous rule. We allow the traffic to the DNS server, but then we restrict the traffic only to a specific FQDN, in this example, SUSECON.com. So from this pod, you will be able to reach SUSECON.com, but you will not be able to reach SUSE.com. One of my favorite in Cilium network policy is the layer 7 HTTP because it's very fine and we use a lot of HTTP services usually inside a Kubernetes cluster. So what we see here, we have until the point 3, we have a layer 4 policy. And again, we just add an extra set of rules at the point 4, where we say, I just allow the method get on the slash metric path. I really like the idea of this rule when it comes to secure an API. For example, you add an extra layer of security. You of course need security at the application layer inside your API, but having the possibility to enforce this at another layer is a great thing for security. The last one from this list is matching a rule using a Kubernetes service account. We've seen so far that we were matching other pods only with labels inside a specific namespace, but here, instead of matching pods using labels, we match the pods by the service account which is used to run these pods. Again, we can thank eBPF for this feature. This is the end of our example, and of course, this is a non-exhaustive list and many other options are available. If you want to know more and go deeper in order to do the lab, you can have a look at the official documentation on the Cilium website. It's a very great resource. To conclude this presentation, let's have a quick look at what we will do during the lab. During the lab, we will start with an environment without any network policies, and we will create some network policies to secure the running workloads and allow the bare minimum between each of the component. This environment and these workloads represent a real-world like use case with two applications, Nextcloud and PrestaShop, consuming a MariaDB database, a front proxy with Envoy, and some tooling around this for monitoring and logging. All right, this is already the end of the presentation. I would like to thank you all of you for listening and see you all for the lab. Bye bye. Hi, and welcome to this lab where we will secure some application on SUSE CaaS Platform with Cilium. I hope you enjoyed the presentation about Cilium and the Cilium network policies and that you're ready to actually see them in action. In order to run the lab, we need this environment deployed on SUSE CaaS Platform with the latest version available, which is at this time the 4.1.2. And these workloads deployed on top of this platform. If you want to run this lab on your side, you can follow the steps in the deployment document in order to get up and running. When the platform is up and running, you should have this component working. We have Hubble UI, we will see this a bit later on. It's to visualize the traffic inside the cluster. We have Nextcloud, which is used as the collaboration tool example in this environment. We have PrestaShop for the simulation of an online shop. We have the monitoring here with Grafana and this CaaS dashboard. Prometheus as well, which is responsible of fetching the metrics. And something which is not in this diagram is the troubleshoot pods. I talk about this in the presentation. It's a way to debug network policies. So inside each of these namespace, we have a troubleshoot pods, which is running with the same labels that you can see here in yellow. Okay, let's get to it. So first, we will start to secure the most important thing, in my opinion, in a cluster, the data. This is the most valuable assets we can have running inside a cluster. Before we start creating some network policy, let's have a look in Hubble UI. In Hubble UI, you can visualize the traffic inside the cluster. In the presentation, I've said that eBPF was really helpful when it comes to visibility, and you will see that right now. So here you can just select the namespace. What we want here is MariaDB. Once we are in the namespace, we can see the pod within the namespace inside the green square, and we can find a lot of interesting information. We can see the MariaDB pod doesn't have any network policy assigned to it because these logs are open. We can see the ports which are exposed from MariaDB. So we have the default MariaDB port and this TCP port, which is the HTTP endpoint exposing the metrics. What's interesting as well is in the bottom of the page, you can see the live traffic. So this is really what's actually going inside the cluster. We can see the source pod, the source service, the destination, the IP destination as well. And you can see if this traffic was allowed or not. Here you can see if some policies are applied. So right now there are none. And you can also use this box to use some filtering when you have a lot of traffic. What's important to know is you really only see the actual traffic. This doesn't mean that there is no other traffic. Maybe right now no traffic is coming in from another pod, but this can come a bit later anyway. Let's have an example. Here we see that we have traffic incoming from Nextcloud and PrestaShop, which are consuming the DB, and we have Prometheus, which is fetching the metrics. In this terminal, we can see the main side where we can use kubectl, so we can see the pods running inside the cluster, and we can see the nodes which we are using now. And on the right side, you have a shell in the famous troubleshoot pods I was talking about before. So let's take this one. We've seen that we have already traffic from MariaDB, Nextcloud, and Prometheus. So let's try to connect from the troubleshoot pods from the troubleshoot namespace to MariaDB. This is a traffic which is not supposed to be allowed, but right now we don't have any network policies. So let's see what we have here. There is a small issue due to comparing. Okay, so right now we've just sent a simple query to MySQL, and we should see now this traffic showing up inside Hubble. Before sending this request, we didn't have any traffic coming from the troubleshoot pods, and we can see now that this is allowed. Again, because we don't have any policy. Okay, now let's start securing this workload. First, what I usually like to do is to create a default policy inside the namespace which will match all the pods in this namespace and deny all the traffic. In order to do that, we can create a default policy. What we see here, we have the namespace. If you remember, all the policies are always namespaced. Here, we don't match any pod by the label. We match all the pod inside this MariaDB namespace, and we don't whitelist anything. Let's apply this. If you remember, we can also find this policy using the short name. We can see it like this, and we can show it in YAML also. From this YAML output, we can see that this policy is already enforced on the two nodes we have in the cluster. If we look in HOL, now all the traffic should be dropped. This is normal because we don't have any whitelist rule yet. And we can see here that the locks are closed. So this means a network policy is applied to this pod. And now all of this is broken. For our first policy, we will only use the layer 3 type of rule. And once we have this policy deployed, we will see how we can visualize and test it. And then we will harden it with layer 4 and layer 7. As usual, let's create the policy. Here we have the description, the name, again the namespace as usual. There is a small difference here. We don't match all the pods, we just match the pod with this label. So if you create any other pod without this label in the namespace, all the traffic will be denied by the default policy. Then we have the egress rule. This one is not mandatory because we have the default one, but usually I like to specify this one as well. Then we have ingress, because if we've seen before, we need ingress traffic. What we see here is very easy and in the same spirit of Kubernetes. Usually it's that we match the allowed traffic using pod labels. So each time you have the namespace where the traffic will be originated and one of the label assigned to the pod. Here you can see we have the network policies. We can again verify that they are enforced. First, we can see if our website is working again. This looks already much better. We can again have a look in HOL and see if the dropped traffic is now allowed. Yes, we can see the recent traffic last seen 1 minute ago was forwarded. We can see the policies here. That's great. Now, let's see how we can test this policy using Cilium policy trace. let's look at this CLI a bit closer. Here we say that we want to run this command inside a Cilium pod. We have the default flags, policy trace, and now what we see is what's the source traffic we want to test. We want to test the traffic with this source, so this Nextcloud label inside the Nextcloud Kubernetes with the destination pod, which is the MariaDB pod inside the MariaDB namespace. This is great. We can see that some rules were selected for this traffic. We found some allow rules, so at the end we can see that the verdict was allowed. Now let's do it the other way around. Can we go from MariaDB to Nextcloud? Yes, we have to update a bit the command. And here we can see that logically the traffic is denied because there is no whitelist rule available. Let's see if we can be reached from Prometheus. We have a whitelist rule, so the final verdict should be allowed, as we can see now. The last way I've presented was to use these troubleshoot pods and use some CLI tool to test if we can connect. Let's see, for example, from the Nextcloud troubleshooting pod if we can connect to MariaDB. Yes, this worked. Let's see from Prometheus if we can curl the metric endpoint. Yes, we can find the matrix. So everything is working fine inside our cluster. Our rules are working. All the supposed traffic is working. But this is not enough. We can do more. What is not enough is that we've allowed the traffic at the layer 3. So this means, for example, that we can connect to MariaDB on the 3306 port from Prometheus, for example. Why? Because we don't have yet some finer rules. And if we take again the matrix example, this is something we can get from Nextcloud, but Nextcloud is not supposed to fetch the matrix. In order to harden this policy, we can first add some layer 4 filtering. What can we see here? We see that all these pods will be allowed to reach our MariaDB pod only on the 3306 port on the TCP protocol. Let's apply this. So right now I should still be able to connect to MariaDB from Nextcloud, but I should not be able to fetch the metrics endpoint. This is what we see here. We won't wait for the timeout, but the traffic is forbidden because it's not explicitly allowed. We can go even a bit further by using this layer 3 as well for the Prometheus pod to avoid the fact that Prometheus can still connect on the MySQL port. With the same principle, we can use this 4 lines and just allow the metrics endpoint. And now I cannot connect anymore to MySQL, but I can still fetch the metrics. But that's not finished. We can even go one step further. We can restrict the URL path allowed and the method used to get the metric endpoint. Here, all we need to define is a new set of rules to define the HTTP path and the method allowed. Now we can apply this again. Here we can still fetch the metrics, but we could not, for example, fetch any other path because this is not allowed. Even if this path does not exist, it's forbidden by Cilium at a lower level. We can as well still verify that everything is working as expected. Inside HOL, we can see that when I try to fetch this URL, it was dropped, but this was allowed on the /matrix. This is really great for observability and to visualize what's going on. HOL is a really great tool. Now let's have a quick look at what we can see using Cilium Policy Trace. The first thing we can try again is to use one CLI that worked before when we tried to see if the traffic was allowed from Nextcloud to our MariaDB. Let's see what we have here. Oh, that's a bit surprising because we know that the application is still working. We can still connect. What's the problem here? The problem is quite easy. Now that we are using a layer 4 network policy, we need to specify the port that we want to test when we use Cilium Policy Trace. So to do so, you just have to specify the port here. And now we can see that the traffic is allowed. It's very important. If you just specify the port like this will not work. If you use another protocol, this will not work. You really have to use what's explicitly whitelisted in the policy. So now, in my point of view, we have quite strong network policy for MariaDB where we have really restricted the traffic. Something that will be interesting and will be in the future will be to filter the same way we do with HTTP, but for MariaDB. Since we don't have any limits with eBPF and Cilium, we could even do some filtering here on the MariaDB side, the same way we do with HTTP, and we could restrict which type of function you can use if you just allow this port to run a select on this table and so on. This is totally possible, and this is something which is in our engineering backlog, and this should be integrated in Cilium in a near future. Okay, now our data is secured at the network level. The next interesting step, in my opinion, is to secure the front end. It's the second most important part to secure in a cluster. Let's see again the traffic we have to allow for Envoy. Envoy is used here as the front proxy for our services. It allows access to PrestaShop, Nextcloud, to MariaDB as well, but in the real world, this is not something we would like to use in this way, but this was convenient for our lab. We have access to Prometheus, Grafana, and Hubble. What's important to know in Envoy is that it also relies on the DNS to forward the traffic to the pod. So we will have to allow the DNS traffic. For this example, I will not define a default policy in the namespace, and I will just directly define some rule on ingress and egress. The first thing we want is the ingress rule. We want to allow an entity which is named the world. The world defines everything which doesn't come from inside the cluster. Let's create the first policy to allow that. It's always the same. We have the namespace. We want to match the label app envoy, but there is a small specificity here is that instead of matching other pods using labels, we use something named entities, and this entity is the role. Then we just simply define the layer 4 rules allowed to get into the cluster. You can verify the rule. It's enforced. Let's see if we still have access. First, let's have a look at Hubble. Since Hubble is accessible through Envoy, we can guess that this worked, of course. But yeah, we can see that the traffic is forwarded. We can see that the Envoy pod is using a network policy on ingress. It's still completely open on egress because we didn't define anything so far. And of course, this is still working fine, no problem. I really like this gecko. Now we have defined the ingress from outside, so from the world. Now we have to define some egress rule for Envoy. So Envoy is allowed to forward traffic to the wanted pod. But like I said before, in order to forward the traffic, Envoy needs to be able to resolve this FQDN here. So this is the services. PrestaShop.PrestaShop is the service. MariaDB.MariaDB is again a service inside the cluster. We can see this service using. So to forward traffic, Envoy needs to resolve, for example, this service PrestaShop.PrestaShop, Nextcloud.Nextcloud. So to do so, we need to allow Envoy to communicate with our kubedns pod. To define this traffic, this is very easy and in the same spirit as any other network policy. This happens at the layer 4. We just create another policy, or we can reuse this one. It's not a problem. We can add them at the list. Let's have a closer look. We are still the namespace, still the label. And here, what we say is we allow traffic to the pod with the label kubedns. So this is our DNS server pod inside the cluster. In the kubesystem namespace on the port 53, and we define any because we could either use UDP or TCP, it doesn't really matter. You can apply this one. Before applying it, I will just go inside the, let's say we will go inside the Envoy troubleshooting pod and see if we can resolve. This is working fine now. We can also resolve the MariaDB service. This is the internal IP. We should be able to fetch the metrics from here. Not that we need it, but since everything is open, it should not be a problem. No, it is a problem, of course, because like we've seen in the presentation, when you want to allow traffic between two pods which are selected in a network security policy, you would need to allow the traffic on both sides. So this is not possible because we already have defined the allowed traffic on the MariaDB side, of course. But I should be able to connect to MariaDB. Let's have a quick look. Yes, this is working. So now we can connect to MariaDB. We have DNS resolution working. Let's apply this now. Let's see what's still working. Can we still resolve? Yes, this is working because this is defined here. Can we still connect? No, we cannot connect. And why? This is simply because as soon as you have a rule defined on egress, you have to whitelist all the traffic that you also want. So here, only the traffic towards DNS is allowed, and we will have to explicitly allow traffic to MariaDB and also to our HTTP backends. Let's do that now. Here I will create a new policy, but it would not be a problem to add these rules just after the one we've defined above for the DNS. This is totally up to you, and it's just then a matter of management and organization. So what we have here, we allow the MariaDB traffic, we allow traffic to Hubble on the Hubble port, Grafana, Prometheus, PrestaShop, and Nextcloud. Okay, now let's try again to connect. This is working, and this should be as well working from my workstation because it's a load from the wall. Let's do a quick try. This is working fine. We can have a look in Hubble to see the traffic. All this drop traffic was the period in between where no policies were applied. All right, so now we have whitelisted all the traffic required for Envoy and MariaDB. Let's have a quick overview of what we've seen. We've seen how we can create policies to allow DNS, HTTP, some layer 4 and so on, but there are many other types to discover, like DNS filtering, filtering on IP and so on. There are so many options available, you can have fun playing with that. Remember to have a look at the official Cilium documentation. It's a great source of example for everything. Here you can see the IPs, you have some layer 7 and so on. So now that you know everything about network policies, you can have fun securing the other workloads of this environment. And if you need help, you can still have a look in the network security policies directory within the repository to find some ideas or some help if you are stuck when you want to secure something. All right. Thanks a lot for being in this lab, and I hope you will have a lot of fun with Cilium and network policies. Bye bye.